We're going to talk about the domain of a function, and here we have a picture that someone took of a castle, which kings and queens have domains, which means it's a particular area that they cover. And we're going to look at a particular area on the chart, which covers the domain of a function. Just by giving a chart, do you have any clue what a domain might be? And you can pause the video and write down your own comments or own maybe guesses. But I'm going to go ahead and tell you right now what domain means for a function, because it's pretty much just a definition. I'm going to give you 3 definitions. The first definition is all the numbers that you can plug into a function and get something back. Okay? All the x values that give you y values or f of x values, and the entire input that yields output. Okay, so it's not just what you plug in. What you plug in has to give you something back. So going back to the chart that we looked at, what are all of the inputs that have outputs? Well, it's just the x values, right? Because every one of these x values has a y value. So simply, domain, again, is what you plug in and get something back. And how do you write it? Well, basically, all of these are just numbers, right? And you're plugging in something and you get something back. You're going to write set notation because they're a set of numbers. We talked about that before. These braces mean set of. And then you're just going to put all these numbers inside of those braces. The order doesn't matter, although sometimes I put them in order from least to greatest, but again, it doesn't matter. And that's it. This right here will give you the domain of the function. It's that simple. It's all of the x values that have corresponding y values. If we look at this this chart, 6 goes to something, and it doesn't even matter what it goes to as long as it goes to something. 3 goes to something, 4 goes to something. 5 does not go to anywhere. This is a function map, remember, and if the arrow doesn't go anywhere, then it doesn't have an output. For example, 9 goes to 1 because of this arrow, so 1 is the output of 9, but 5 has no arrows. So when we go to write the domain, we can only write 3, 4, 6, and 9. We cannot include the other 5. The 5 does not have an output, so this is the domain of this particular function g of x. Example 3. Here we have some inputs. They all have outputs. It's the same output, but it doesn't matter, right? Because they all have only one unique input. 6 has one output. 3 does not have any other outputs. So it doesn't matter if they all have the same y value. What matters is each only has one and no more than one y value corresponding to it. So these are all my inputs, and I'm just going to put them inside of braces and separate them by commas, and that will give me my domain. It's very, very simple. What's the domain of this set of points? Well, notice every number 4, 1, 12, 2, -8 has an output except for 0. 0 is undefined, so that means there's no point on the graph at 0, so we cannot include it in the domain because remember, domain, all the x values that give you an actual f of x value back, and undefined is not an f of x value, so it's not included. 0 is not included in the domain, but every other number is included in the set. Here we have a chart, and if you notice, e, which is a number, does not have an output. 4 does not have an output. The only number that has an output here is -10. It outputs to -4, so therefore the only domain is -10 for this particular function, which is okay. It can still be a function and be a single point. The key is it has one input that goes to an output, so the domain is just one number. Example 7, what's the domain of this function? Input is going to be the food that you eat. Output's going to be the result. And so basically, you're just including all the inputs in because they all have outputs. Okay? So your inputs: chocolate, apple, beef, beans, onions. One more example. When you have a computer, you have a set of inputs and outputs. So for this particular example, we have a mouse, a keyboard, a microphone, a power button, and a camera. Now we could generalize it and say computer parts, put that in braces to generalize it, or you could actually take each individual component and put it into braces and that would give me the domain or the set of inputs of this function. If you have any other questions about domain, let me know.